In the question number 36, a ball is thrown from the top of a tower, height 63.8 meter, with a velocity of 30 meter per second at an angle 37 degree above the horizontal. The angle formed by the velocity of the stone with the horizontal when it hits the ground is, and you can take small g is 10 meter per second square. So if I make the diagram, suppose this is horizontal ground and this is the point of projection, and we know we will take origin at the point of projection, and this height is 63.8 meter according to the problem. So as per the situation, when you will throw the ball, it will hit the ground just like that. So if I consider this is the horizontal component of velocity and this is the vertical component of velocity, but according to the problem we need this angle alpha. So my requirement is alpha, and we know we can calculate tan alpha by using vertical component of velocity, horizontal component of velocity, because we are looking for the angle. That's why I am going to use the mod. So our requirement is first Vy, how you will calculate. Another requirement is Vx, how you will calculate. So we'll see. If I use the equation of motion along x-axis, Vx ux plus ax into t. As I said in the previous question also, if there is no retardation along x-axis, if there is no air resistance, then acceleration along x-axis will be 0. So I need horizontal component of velocity at the point of projection. So we know, because ball is projected with velocity 30 meter per second and at an angle 37 degree. So if I take the horizontal component, that is 30 cos 37 degree. So when I will write 30 cos 37 degree, but there is no horizontal acceleration, so I have only 30 into the value of cos 37 is 4 upon 5, you know, 5 6 ja 30, so we have 24 meter per second, and this is the value of Vx at the point of hitting point, जहां पर hit कर रहा है उस point पर. The second requirement is Vy, so I am going to take equation along y-axis, Vy square in terms of position uy square plus 2ay into y. Ay means acceleration along y-axis. So first my requirement is uy. Uy is the initial vertical component of the velocity at the point of projection, means here. So you will write initial velocity 30 and vertical component sine 37 degree. So when I will place the value uy means 30 sine 37, 30, and you know the value of sine 37 is 3 upon 5, 5 6 ja 30, will get 18 meter per second. So when I will place this value in the equation number 2, if I consider this is my equation number 1, so uy is 18 square, because my point of projection in this point at height 63.8 meter, and finally ball will come down. So that's why I am going to take acceleration due to gravity as a negative 2 into 10. But you have to be very careful when you will place the value of y, because your point of projection is this and finally hitting point is this. So you are looking for the blow of origin, यानी origin से नीचे की तरफ आप जा रहे हो. That's why I am going to take minus 63.8. So when you will solve, will get 1600 if I take only Vy. So when you will solve, you will get 40 meter per second. and this is the vertical component of velocity at the hitting point. So now I have Vx, that is 24 meter per second, and I have Vy 40 meter per second. So for further calculation, we will use the next board. Now tan alpha is Vy Vx. So when you will place the value of Vy, that is 40, Vx 24, on solving you will get 5 by 3. So alpha is equal to tan inverse 5 by 3. So this is the final value. So on behalf of that, we can say my option number 1 will be the right choice. So let's move on question number 37. In the question number 37, two stones are thrown simultaneously from the same point with equal speed v0 at an angle 30 degree and 60 degree. Respectively with the positive x-axis, the velocity with which stone moves relative to each other in air. So if I make the diagram, suppose point 2 is the point of projection and this is x-axis, this is y-axis. So if I consider the velocity of first one is v1 with vector, and according to the problem angle of projection is 30 degree, and the second one if I write by v2, then angle will be 60 degree, right? So if I make the velocity vector for v1 and v2 first, so I will write v1 is v1x plus v1y, v1 along x and v1 along y. So v1 means, because you know there is no horizontal acceleration if there is no air resistance. So if I resolve the two component of the velocity and v1 is the final, so first I will write v0 cos 30 at any time. This component of velocity will remain same, but when you will move along y-axis, then you know uy minus g sin theta. So I will use v0 sin 30 degree, initial vertical component of velocity, minus ay into t, because ay is g and time, if time t along y-axis. So final velocity vector of v1 for any instant. Similarly, if I make for the v2, so we'll write v0 cos 60 I cap, and similarly for v2, so v0 sin 60, and this is the initial vertical component of velocity for v2 minus of gt j cap. So ये दोनों final velocity vector है. On the other hand, you can say v1 and v2 are representing the velocity vector at time t for v1 and v2 both. And now as per the question is asking to us the velocity with which stone move relative to each other. So now I am going to use the relative velocity concept. v21, velocity of 2 relative to 1. So we'll write v2 minus v1. For further calculation, I am going to take another board. So we'll see. Now first I will write the value of v2. So that is v0 cos 60 I cap plus v0 sin 60 minus gt j cap and minus. Now I am going to place the value of v1. v1 is v0 cos 30 I cap plus v0 sin 30 minus gt j cap. So you are saying that जब हम इसको माइनस करेंगे then gt यहाँ पे माइनस है, ये प्लस हो जाएगा, then gt will cancel out, and if I take v0 as a common, then you will find only cos 60 degree minus cos 30 degree I cap. If I take I cap as a common from both brackets. So we'll see next part will be sine 60 minus sine 30 j cap. But if I go for the magnitude, we'll get V naught cos 60 minus cos 30 with the square plus sine 60 minus sine 30 with the square, and when you will place the value and will solve, then you will get 2V naught sine 15 degree, and this is my final answer. So if I see the options, we'll get option number 2 will be the right choice. So let's move on question number 38. In the question number 38, and I would like to say this is very important question for us, NEET के according, this is very important, so you can mark as a very important. In a political rally, a guy from audience threw a flower at leader. The flower travels a horizontal distance of 20 meters. In 1 second before hitting the leader face, 1.75 meters above the stage, the flower is thrown from 2 meters above the horizontal with initial velocity, which is making an angle 37 degree above the horizontal. The height of stage above the horizontal floor is. So this is your point of interest or your target. You can take the value of G once again, 10 meters per second square. So I would like to make the diagram first. Suppose at 2 meter height, according to the problem, we'll see flower is thrown from 2 meter above the horizontal. So this is 2 meter, and if a guy throw a flower, let us consider this point is face of leader. Face of leader. And this height according to the problem is 1.7 meter. So we'll write here 1.75 meter. This one. And the angle of projection at the horizon was 37 degree. So if I resolve the two component of velocity at the point of projection, we'll get horizontal component u cos 37 and vertical component u sin 37. But according to the problem, one point is very important. The flower travels a horizontal distance of 20 meter in 1 second. So this distance is 20 meter. The time is 1 second. So this is the scenario of this question. Now I am going to solve this. First I am going to use this value 20 meter. So you can take just like a horizontal range. So if I write horizontal range, you know we need horizontal component of velocity and time t only. The complete equation is half axt square. But you know ax will be 0 because there is no air resistance. So if I place the value of horizontal range, that is 20, ux is u cos 37 degree. So we'll write u, the value of u is u cos 37 into, I need the time. But question says 1 second before hitting the leader face. So this is the time of flight or time, total journey time. We'll write 1. Cos 37 is 4 upon 5. So u into 4 upon 5, that is equal 20. So 4 5s are 20. 5 into 5, 25. So you will get u is equal to 25 meter per second. Now I have the value of velocity, this value, projection value. जिस वेलोसिटी से थ्रो किया वो मेरे पास है, बट आई नीड, सपोज दिस इज द हाइट h फ्रॉम द ग्राउंड, मुझे चाहिए द हाइट ऑफ स्टेज above the horizontal floor. So if I use the another equation, so we will solve this equation in next page. So we'll see, if I use y equal uy into t plus half ay t square. First I am going to take y. We'll see h plus 1.75 minus 2. So what is this? We'll see. Suppose this is the h. So you are saying that from the ground to the point of projection is 2 meter and height of this is 1.75 meter, and from this point to the ground is h and your point of projection is this. ये जो 2 meter है ये point of projection से नीचे है. So when you will take proper sign convection, then we'll write h plus 1.75 minus 2, and that is equal uy. Uy is uy into t, but acceleration due to gravity will be negative, so minus half gt square. Now I am going to place the value. Uy is u sine 37 degree into t minus half, g is 10, time t is 1 second. You can place t is 1 will be here. यहाँ भी हम place कर सकते हैं. तो now value of u I know, that is 25 sine 37 minus 2 5 ja 10. So you have only 5. The value of sine 37 is 3 upon 5. So when I will place the value 25 into 3 upon 5 minus 5. 5 5 ja 25, 15 minus 5. So final value is 10. But I have h plus 1.75 minus 2. But our requirement is only h. So when you will go for h, we'll write 10 plus 2 minus 1.75. And when you will solve this equation, you will get 10.25 meter only. So this is how you can deal this type of question. So you have to be very careful regarding this. So now I am going to take my options. So we'll see. As per my discussion, we can say my option number 3rd will be the right choice. So let's move on question number 39. In the question number 39, a river is flowing with a speed of 8 km per hour. A swimmer wants to reach point R from P. He swims with a speed of 8 km per hour at an angle theta less or equal to 90 with respect to river flow. If PQ, QR 800 meter, then value of theta. So this is very important point. PQ, this PQ and this QR is given 800 meter. Then I need the value of theta. So we can solve this equation by using some logic. Suppose this is D. And if I resolve the two component of this, let us consider this is V. So we'll write this is horizontal component V cos theta and this is V sin theta. So if I want to solve this value of D, then who will be the responsible? Which component will be the responsible? So there is no hesitation, you can say V sin theta. So if I write D, D is equal to V sin theta speed into time. If I place the value, because D is 800 meter as per the question, so we'll write 800 and V is 8 kilometer per hour, so I will write 8 sin theta into t and this is my equation number 1. लेकिन अगर हम बात करें कि the flow of river on the right hand side, then drifting will take place and which component will be responsible for the drifting? So you can say, if I say drifting along x-axis, so x is equal to, we need horizontal component v cos theta and plus the velocity of river also, because the flow of water will be the responsible for the drifting. So we'll write VR, R for river, and we need time t. So this is my equation number 2. If I place the value x is equal to 800, कहाँ से मिला? Because question is saying QR is also 800. So 800 and V is 8 cos theta plus. I need the flow of river. River is flowing with speed 8 km per hour. So we'll write here 8 into t, and this is your equation number 2. But you are saying that the value of 800 is 8 sin theta into t from equation number 1. So if I use this equation number 1 and I am going to replace the value of 800 in terms of sin theta, so what you will get? We'll see. I will write here 8 sin theta into t in place of 800 by using equation number 1. So we'll get 8 cos theta plus 8 into t. T will cancel out. And if I take 8 as a common, so we'll see 8 sin theta and 8 cos theta plus 1 only. So 8 will cancel out. So I have sin theta minus cos theta, that is equal 1. So you have this equation number 3rd. But I need the value of theta. So for finding the theta, I am going to use the next board. We'll see. You have to be very careful regarding this point. So I have sin theta minus cos theta and 1. यहाँ पर आके थोड़ा सा प्रॉब्लम हो सकता है. तो we'll see. If I multiply by 1 by root 2 into sin theta minus 1 upon root 2 into cos theta and 1 upon root 2. I am going to take a multiplication by 1 upon root 2 on both sides. But क्यों? क्योंकि sin में 1 upon root 2 value 45 का होता है, cos में भी होता है. That's why I am going to use this. So what you will get? I will write cos 45 in place of 1 upon root 2 and sin theta will be here minus. We can write sin 45 in place of 1 upon root 2 and cos theta will be here, and that is equal 1 upon root 2. So sin A, cos B, cos A, sin B. So we can write here sin theta minus pi by 4. Pi by 4 means 45. And that is equal to 1 upon root 2, and you can write 1 upon root 2 means sin pi by 4. So you can compare sin with sin. So I have theta equal pi by 4 plus pi by 4. So you will get pi by 2. So we can say theta is equal to 90 degree. So this is how you can deal this question. So by this calculation, I am going to take my options. So I can say my option number 1 will be the right choice. So let's move on question number 40. In the question number 40, if 3y equal 4x minus x square is the equation of path of projectile, then which of the following is incorrect? So this is very dangerous word for us. Incorrect. यानी जो आंसर रॉन्ग है वो हमारे लिए करेक्ट है. G is 10 where x is along horizontal in meter and y is along vertical in meters. So this is a general term. So how you will solve this question? So I will start one by one and try to find out which one is correct and which one is incorrect. First I would like to write the equation for projectile motion or path of projectiles, and that is x tan theta minus 1 by 2 gx square upon u square cos square theta. So this is the equation. Now, so I am going to start one by one. First, the equation is 3y 4x minus x square. So when I will compare this equation with the general equation, the coefficient of y is only 1. So that's why I will write this equation like that. 3 को transfer करूँगा 4 by 3x minus 1 by 3 x square. So if I take 4 by 3x as a common, so we'll get 1 minus x by 4. If you are looking to find the value of horizontal range, then you can put y is equal to 0. You know very well. So when I will place y is equal to 0, I have 1 minus x upon 4. That will give you x equal 4 meter, and this is horizontal range. Right? So now I am going to take x is equal to 4 meter. So if I read the option number 1, option number 1 is saying horizontal range is 4 meter. Yes, so this is the correct statement or true statement. But I need incorrect. So I will check the another option also. So if I go for option number 2, angle of projection. So for the angle of projection, if I compare this equation by our equation number 2, so we'll see x tan theta from the general equation and 4 by 3 x from equation number 2. So x will cancel out. So we can say theta is tan inverse 4 by 3, and this is the angle of projection. So in the option number 2, angle of projection with the horizontal is tan inverse 4 by 3. So this is also true statement. But I need incorrect statement. That's why I am going to take my option number 3, time of flight. So time of flight, you know, in the case of horizontal range, I will write horizontal component of velocity u cos theta into t. So if you are looking for the time of flight, you will write t equal r upon u cos theta. I have the value of r, that is 4 meter, but I don't have any idea u cos theta. So now you are looking to find the value of u cos theta. कैसे करेंगे? देखिए, the coefficient of x square in equation number 2 is 1 by 3, right? And the coefficient of x square in your general equation is g upon 2u square cos square theta, right? So if I place the value of g, that is 10, so 2 5 ja 10 and 3 will be here, u square cos square theta. So when you will solve, you will get u cos theta, and that is equal root of 15 meter per second. So this is the value of u cos theta. When you will place the value of u cos theta, you will get t equal, because range is 4 and the value of u cos theta is root 15 in terms of second. So if I read my option number 3, time of flight is 4 upon root 15 second. So this is also true. अब मैं कह सकता हूं कि option 4 ही right choice होगा. But ऐसे कैसे बोलूं? So now I am going to solve for option number 4. So we'll see in the next board. Now I am going to solve option number 4. In the option number 4, if I divide height with the range, so you know u square sine square theta upon 2g is the formula of maximum height, range 2 sine theta into cos theta into u square divided by g. So g u square sine square theta with the sine will cancel out, and I have only h upon r sine theta, and this cos theta will convert into tan theta divided by 4. But I am looking only for height, so we'll write r tan theta by 4. The value of horizontal range is 4 and the value of tan theta is 4 by 3. Divide by 4. 4 will cancel out. So I have maximum height is 4 by 3 meter. So this is the maximum height. Now I am going to take my option. So we'll see. If I read the option number 4, maximum height is 2 root 15 meter. So this is not true. So this is the incorrect statement. So we can say my option number 4 will be the incorrect. And according to the demand of the question, my option number 4 will be correct choice. So let's move on question number 41.